for today's presentation of the Yaskawa webinar series. I'm Greg Smith. I'm a member of the marketing team here at Yaskawa Motoman. For those of you joining us for the first time, we do these webinars on average a couple times a month on topics ranging from product spotlights, emerging industrial technologies, and even how-to tutorials. We do them every couple weeks on average. A little less often during the holidays, but be sure to sign up for future webinars on our website. A couple announcements before we introduce our presenter. Everybody who registered will get an email with a replay link and a link to our webinar archive on our website. It'll typically be a couple hours before the webinar appears on the website. Then also, if you have any questions at any time during the presentation, you can submit them via the chat console. We've got a Q&A session at the conclusion of the presentation. We also have moderators who may be able to answer your questions in real time. Today's topic is robotic adoption in the logistics supply chain. And today's presenter is Roger Christian. He's Yaskawa's leader of new business development. His role is to recommend areas for strategic investment and product development in emerging markets. He's been with the team for 31 years, and he currently serves on the Technology Advisory Committee of the Advanced Robotics and Manufacturing Institute, and is also a member of the Ross Industrial Consortium. Please welcome Roger Christian.
Hey, Greg, thanks for the intro. Hi, everyone. Thanks for joining.
On you.
Robotics and logistics is real, and it's becoming a necessity for those companies that move goods from business to consumer. I put together this presentation to give you a sense of what is possible now with the advancements in 3D vision, processing speeds, and AI. I'll talk about the enablers and show you leading edge suppliers that are making this all possible. So for now, I'm going to turn my camera off so we get a more full screen, and we'll proceed to the next slide. Okay. So on the agenda, I'm going to talk a little bit about Yaskawa. I promise only 2 slides. A brief review of the market growth and scarcity of labor the logistics companies are dealing with, the enablers, which have been percolating for at least a decade and are now coming into fruition, and then application examples of how robots are currently being used to help manage the great exploding warehouse. As you can see, our Eric Neves of Plus One has described in videos in the past. Okay, Yaskawa Electric Corporation, which is our parent, is a leader in robotics, motion control, and variable frequency drives. Best known for product diversity, quality, global footprint, and our superior customer support. And their vision is to embrace and encourage innovation internally and with our partners. Yaskawa America is comprised of 2 divisions, the robotics division, which I work for, Greg, and our motion and drives division. Our robotics division is staffed to fully support the engineering and development needs for our North American customer base, and includes an aftermarket support team of over 125 people. It's important to know also that every employee is eligible for a variable bonus based on our customers' annual satisfaction survey. So from the maintenance crew all the way up to the CEO, we take customer satisfaction important. So let's spend a minute on the market size and growth projection. You can see there's 18,000 warehouse locations in the US, 4 million employees in distribution and logistics. There's a projected 40% of retail sales will be through fulfillment by e-com. It's currently 15%, so it's growing fast. And it's a large market. 1.3 trillion is projected just for the 3PL market, third-party logistics market, by 2027. And an average warehouse could have as many as 1,500 employees. So if you look at the graph I put in there about e-commerce growth, you can see that it was humming along at a nice growth pattern. And then all of a sudden, this little virus took over, which I call the COVID effect. And it has spiked the demand for online deliveries versus brick and mortar. We continue that spike to level off, but this has helped fuel the drive and the need, or let's say driven the investment and the need for robots. The familiar quote is, "I can't find workers that want to do this work and must continually deal with high turnover." In fact, Amazon had to cancel building several DCs because of the local unavailability of labor in that area. And face it, this is not rewarding work. Plus, the DC, the logistics companies are facing rising wages. Personally, I'm okay with that part, but let's give them more meaningful jobs managing robots instead of picking up boxes. So while the birth of robots started in the early 60s when Joe Engelberger founded Unimation, it really wasn't until the mid-80s that robots matured and were acceptably fast, reliable, repeatable, and affordable. I call that the first wave. But using a robot still required a rigidly defined specification and usually suitable only for high-volume, low-mix products. Robots were basically blind and followed a carefully scripted program requiring skilled programmers and engineering folks to develop it. Enter new advancements in commercialization of 3D vision, sensors, computational computing power, and artificial intelligence. We can thank our gamers for that, a lot of that development actually. So they're now becoming more affordable and capable for implementation on robots in low volume, high mix apps, unstructured environments, with limited knowledge of part size, part shape, or orientation. This is what I call the second wave, and it's very exciting, and it's really started up only in the last 4 to 5 years. So these advancements have opened up many new market opportunities for robotic automation, and the list continues to grow. I've shown you 4 here in logistics, food prep, agriculture, and cobotics, or human-robot collaborative manufacturing. I will mention that Ross Industrial has played a big role in accelerating the 3D AI robot startup community with their open source software modules. So let's discuss the need and the enablers. So the need, obviously, we've broached before, is the e-commerce revolution. Then add COVID on top of that, which accelerated the growth at fulfillment centers such as Amazon and Walmart, parcel delivery such as FedEx, Pitney Bowes, and of course labor shortages and rising wages. Actually, e-commerce model requires more labor than brick and mortar model, because you're moving products to brick and mortar in bulk. The interesting enablers is GPUs, graphical processing units, and this really came out of the gaming industry to stream images very quickly and crisply. This is perfect for analyzing the images you get from what I call a connect effect, or basically 3D cameras or sensors. So that's the perception side. And then grasping is still very important, and it is kind of built to purpose, whether you're each picking or parcel picking or sorting or inducting. Cobots can play a role in some places, but usually industrial robots are desired because of the speed that they can run, and then funding. So all that together adds up to, smart robots. Yeah, so how does this all come together to make smarter robots? I'm not a software engineer, but I did stay at a Holiday Inn Express. I find this one of the best 3-minute video clips to explain how 3D vision AI technology is enabling our robots to help automate the needs of our logistics customers. So Greg, you want to cue that up?
Supply chains are innovating. E-com keeps driving volume. Customers continue demanding shorter and shorter delivery times. As a result, we're all looking for ways to manage what I call the great exploding warehouse. If your job in the warehouse is to depalletize off of a 48 by 40 skid onto a conveyor, your workday is measured in tons. These are hard jobs to fill. They're even harder to retain. So Plus One set out to help. We applied our 3D vision and AI tech to this application. Pick One is our vision software, and it makes unloading pallets in warehouses, fulfillment centers, and DCs a reality. A full pallet is placed in the pick location. Pick One immediately begins to image the items to determine size, shape, location. The software then determines which ones are pickable, assigns each of them a specific confidence level, and commands the robot which item to go fetch. The reason you need robots and vision to do this is that pallet mix has changed. Operations are requiring mixed pallets, rainbow pallets, and once you have different heights in the same layer, traditional automation breaks down. This is all solved by Pick One, which can manage the individual cases. The software is so robust that the robot can easily induct items off a pallet of randomly oriented cases, cartons, trays, even bags right onto a conveyor. The robots are able to easily unload a variety of pallet layers, including those with overhang. We've designed it to work with any robot solution at scale. With Pick One, the robot tackles new SKUs with ease, performance improves over time. What do we deliver? We deliver reliable, consistent throughput. We can even ensure the safety of your workers by moving them out of these repetitive injury-causing tasks and promoting them to higher value work. We do that by using Yonder, an application that gives us the opportunity to employ a crew chief. That's a person who can remotely manage dozens of robots at a time from a workstation. I want to go back to this idea of confidence levels. It's an algorithmic measurement for how confident the software is that the robot will be able to pick up and place an item correctly. High confidence levels result in automated picks. But if all the packages or items show low confidence levels, Pick One instead sends a Yonder request so that the crew chief, this person, can now step in and manually handle this exception remotely. And because Yonder stores the crew chief's responses, Pick One systems become smarter over time.
Thanks, Greg. Okay, so I'm going to talk a little bit about induction sortation, palletizing, AMRs. So let's first talk about parcel induction. What is it? So it is picking parcels from an incoming jumbled pile and inducting into a conveyor for scanning and sortation. So this is an image taken at FedEx, Memphis, which is the express group that overnights billions of packages a year. And this is easy for a person to do, but it's very boring. AI provides continued refinement of a robotic picking system and increases throughput rates. So as the more samples it sees, the more possible mistakes it makes, like a double pick, it will continue to improve, and that will bring up picks per hour rate. And then there, as Eric mentioned in the video, there's human in the loop capabilities that reduces downtime for simple hiccups, like the vision system has a low confidence level. Someone can pop on and point to the right product to pick. It's off and running instead of calling a maintenance person that could be a quarter mile away in the facility. Should play that video real quick. It's a little short, just showing how that works. So this is the induction. Once it gets into that conveyor, it goes through an automated sort system and sorts by zip code down a couple floors, gets rebagged and put into an airplane again, or a delivery truck. So you can see how these things just clump in, and this is where the vision and the robot picking take place. The indexing of those big clumps of small parcels is operated by the person with a foot pedal, so they can slug them in. So here's, you can play that, Greg. So here's a video of the first 4 robots that were installed in Memphis. We have 12 more systems on our floor right now that deciding when's the best time to put them in, before or after peak sortations, peak mail flow, which starts in mid-November. And this system was included Yaskawa as the main system integrator in this case, and +1's vision, and Yonder, as well as, of course, FedEx as our customer. So the vacuum has been proven to work best for parcel induction and sortation because it can pick up a variety of shapes and sizes. There are 2 cameras on this each picking station, one in for the pick tray where it's picking the product, and one at the place conveyor. At the place conveyor, it determines whether the product is properly oriented to fit through the conveyor opening, as well as if there's a double pick, it will reject those backwards down a chute. You can see where that person is walking there. Instead of repicking and dumping back into the pile, and it's just faster to reject them and then reinduct them manually at a later time. So this example is sortation. So sortation usually requires someone to induct the packages, singulate them, if you will, and then scan it for scan the barcode for the bin location. These sort trays are basically being sorted for zip code, and these totes will be pulled out and either sent via truck to another a depot, or right on a delivery truck for local delivery. This system was built by Dorobot, which is another 3D AI vision company. The customer is DHL, and I think this is a, believe it or not, this is a Yaskawa robot. That's just DHL yellow. And when Greg cues this up, we'll hear from DHL's Zenaida Villatoro.
Working with DoorBot has actually been a game changer for us. We've been able to bring in robotics, automation, innovative solutions to a task that is manual and we do every day. It's just been amazing to be able to provide more accuracy, more efficiency in our operations.
Oop, turn my mic on. All right. So now, what if you combine parcel, induction, and sort in the same system? So this was done by a company called Robotics.
Robotics is on a mission to empower people to work better with smarter tools. As e-commerce volume continues to rise, global brands need pick and pack support more than ever before. With AI-powered robotics, Ambi solutions are designed to help your team handle more. AmbiSort is a new type of highly dexterous robot that comes ready to sort millions of items in your warehouse on day one. With the repetitive parts of sorting automated, you can have associates do higher value tasks. Ambi systems are powered by AmbiOS, an advanced operating system that leverages DexNet, a proprietary simulation-to-reality technology that teaches robots to pick and pack millions of items rapidly. AmbiOS can power any type of hardware configuration. Modular hardware and software allow Ambi systems to quickly integrate your existing process flow, with inputs and outputs customized to your needs. By completing millions of cycles in simulation, AmbiOS trains robots in hours, not months, 10,000 times faster than other solutions. AmbiSort is highly dexterous, able to pick up rigid or deformable packages, and can even reach deep inside bins. They're simple to use, with intuitive dashboards and notifications to keep operations flowing. Roll up, push go, and AmbiSort's UI will alert you when bags are full. AmbiSort is efficient. With increased uptime and optimized flow, AmbiSort can increase your throughput by 50% and reduce operating costs by 40%. Ambi Robotics integrate with legacy systems, so you can easily scale up. There's no need to reconfigure or invest millions in static infrastructure. Better data means better process visibility, like package weight for accurate shipping costs and data flows to learn what causes bottlenecks. At Ambi Robotics, we scale AI-powered robotic systems to ensure our partners have the pick and pack support they need. Expand your sorting capabilities and scale to meet peak demand. Help your team handle more. Ambi Robotics. Learn more at ambirobotics.com.
Thanks, Greg. What's unique about Ambi is one thing that they not only manage adding intelligence through the sensing, the vision sensing, through their AI engine, but they also can, based on what they see, they can decide how to pick the product, and they have developed their own end-of-arm tools, so they can use that big suction cup up front, or all three of them, or two on the back. So that adds a little more flexibility and control on their side. Now, adding or combining inducting and sorting together, it's going to be a lower rate than if you separated them. This installation is for Pitney Bowes, and obviously you saw it had a lot of flexibility in inbound and outbound container options. So now I'm going to switch gears from, let's say, the courier business of moving parcels to online order fulfillment. The images you see are typical online order picking. They either use pick-to-light or pick-to-voice technologies. And, there's lots of walking. It's not optimized for footsteps, that's for sure. And pick accuracy can be compromised due to human error. And don't forget that each pick location needs to be manually replenished. I can say that. An equal amount of activity is needed to replenish the bins as it is to pull out and pull for an order. And, you know, obviously somebody's order doesn't necessarily going to be 2 bins next to each other. So there's lots of walking. So online order fulfillment, so we call it each picking, piece picking goods to robot. Supplier product arrives to a fulfillment center. It's put into unified totes, usually stored in an ASRS, and then pulled and picked for custom orders. So it eliminates you're moving the goods instead of the people to the locations, and the bins come to either a person or a robot. So Greg, why don't you run that video? Oh, I'm sorry. I apologize. All right, so you can play this video, and we're going to talk about order picking and building kits, medical kits in this case. So robots are typically dedicated for each incoming type of product that's brought in a tote, and then sequentially build the kit as required as the kits move down a conveyor line. So it's very flexible and easy to change over to new kit build recipes. So if you see the small ampules, they're a little more difficult to pick than, let's say, boxes or parcels. It simply would require a higher resolution camera to image that. This system is provided by another startup called Capson Robotics out of Pittsburgh. And you can see the diversity of the products, and it builds the kit as required. New kits needed, you bring in new totes for products, and off you go.
Somebody in the audience mentioned that there was no audio on the previous video. Would you like me to go back and replay that video? Yeah, it was
Mugen?
I believe so. I can cue it up if you'd like.
So I
Yes.
was muted when that played. Okay, sorry. We'll go through that again. Oh, that's not the one. All right. Yes, this is the one. All right. This system was built by Warehouse Automation out of Canada. The software and the vision is provided by Mugen. Mugen is a Japanese company that has recently put an office in Atlanta, and very sophisticated software, not only in finding and picking objects, but also sequentially and on purpose placing them in the right place in the case. This is what's feeding these totes is an ASRS system. So on the back end, people would be filling products into the totes. They'd be stored in a location, and when an order comes in, it'll pull that tote to a pick station, which traditionally has been a person, and now we're putting robots there. So in case of, this could be a one robot application or two, depending on throughput, but it can neatly organize the product into the shipping case, which is desired. So it's less touches, goes from adding the product to the tote, picking it from the tote, and putting it right in the shipping box. So very efficient in terms of number of touches. And certainly if there's attributes on the product of whether they're crushable or delicate, then the Mugen software has enough sophistication to place those carefully in the outbound. Okay, we need to rerun this one, or are we okay, Greg? Okay.
That you had identified on for this slide. Would you like me to play that? Okay.
No. I'll let me advance the slide. All right. So let's talk about palletizing and depalletizing. And I'll start with what's easiest to what's more difficult. Single case homogeneous palletizing has been done for years. It's straightforward, but limits product variability without some possible offline programming software assistance like our pallet solver software, which allows you to change product size and pallet patterns very easily offline. Next is mixed case depalletizing, which is requires 3D and AI vision. And then the last, which is kind of the holy grail, which is mixed case palletizing. And that requires the same 3D AI vision tools, but also requires some type of intelligent palletizing software. We'll talk about that in the next couple slides. Go ahead and play those. So here's one example of a highly optimized bag palletizing cell. It's set up once. It's an OEM product, so there's moving like, I don't know, 75 or 100 of these a year, and it uses traditional pendant programming. It's optimized for throughput. So this system with our palletizing robot and a very nicely designed bag gripper can palletize up to 30 bags per minute. So the robot is jacketed for the corrosion resistance of the salt when we're picking up salt. This will do dog food, all kinds of grain products as well as salt products. You all been by Lowe's and picked up your softener salt. You move to the next one if you can, Greg. So this one is kind of highlighting the offline programming piece of it, and the integrator here developed a multifunction end-of-arm tool to handle a range of product sizes and also to place slip sheets if needed. Again, this is a non-vision palletizing application, but they developed it all in offline software called Motosim, which is our product. And as long as you justify the pick and place positions and pallet positions after the offline programming step is done, you touch off where those hard points are and you're off to the races, and not doing a lot of hand programming. Pretty fast, eh? Of course, if product size changes to a great degree, you can always tool change, and if you need a different kind of end-of-arm tool. All right, cue that up, Greg. So this is an example of mixed case depalletizing. And again, as I said, it requires a 3D vision system and AI to get faster and better. And it determines individual product size, elevation, and location of each case. This happens to be through Boston Dynamics, who bought a company called Kinema Systems about 3 years ago. The best depalletizing companies or vision companies can determine if, let's say, two tightly packed cases that are the same, look the same, are either one big case to the vision system or two small cases to avoid mispicking. This is where the vendor's AI engine is critical, and the difference between it kind of works and it's awesome. So depalletizing mixed cases or mixed layers can achieve rates of around 800 picks per hour. This technology is available from multiple 3D vision companies, as well as from some of the more traditional logistic automation suppliers. When looking and thinking about depalletizing, you may want to consider the vendors that offer, a human in the loop type feature, like you saw with Plus One at Yonder, with their Yonder products. Okay, now we're moving into the holy grail side of robot palletizing, which is mixed case palletizing. The demand of mixed load pallets from retailer distribution centers to their outlets is in high demand as in-store warehouse space shrinks and online ship to store demand increases, like from Walmart, Target, Lowe's, Kroger. So typically in these warehouses, you have inbound monolithic product. It is layer depalletized and buffered into an ASRS system and then fed to a mixed case palletizing station. In this case, this is Robotic, and then it ends up in a nice, tight, packed, outbound pallet ready to go. So this just kind of illustrates that, an order picker nightmare trying to solve the Tetris equation when products are coming at you and you're tasked with palletizing it and trying to fit everything in. So there's companies out there in this, like WSR that we're working with, that has this intelligent palletizing software, and it quickly calculates the optimal pallet build configuration based on the customer's specific order data. So we'll get a request for a pallet SKU load. It will look at all the products that are getting fed down and look at the attributes of the product, its size, its weight, its crushability rating. So you're not going to put, pop on top of potato chips. And then it coordinates the product feed and from the ASRS. So the ASRS is feeding in sequence what is needed to be palletized on layer 1, layer 2, layer 3. So this creates a high density pallet build and a fairly stable one. If we go back and look at this, why they are so elevated is as the robot builds a layer, it then lowers down through a hole in the platform and stretch wraps that layer and then builds the next layer and so on. And the 3D AI piece is used as a quality assurance to make sure the layer build is stable and nothing fell off or tipped off. Okay, so here comes the mobile robots. Recent advancements in LiDAR area scanners, high-speed wireless networking have really unleashed a new brand of mobile robots called AMRs, autonomous mobile robots, versus AGVs, which are automated guided vehicles. Amazon bought a small company 5 or 6 years ago called Kiva for a small fee of $770 million and turned the traditional fulfillment model on its head. So instead of walking aisles and aisles and aisles to pick an order, they bring the aisles to the people, and the people pick off these mobile vehicle carts that are on top of it. But the Amazon robots are AGVs, so they follow a grid pattern that's on the floor. And the whole, let's say, mobile pick warehouse on these racks is still behind a fence because it does not have the area scanning capabilities for safety. You can see them here in action if you can cue that up. Great. So you notice the incredible density. This is basically a really high density warehouse of product. And it's part and parcel due to the AGV's capability for zero turning. So they can work on this really tight grid pattern. I call it whip on wheels. And Amazon has really taken advantage of or optimized the number of touches, the 3-touch principles here. A person loads the cart and they can put a product in any cubby hole, scan it, and it knows where it is and knows how to retrieve it. And then pick the order from a cart that moves to an operator station, and using laser light, pick to light technologies, it tells a person where that product is and which bin location, and that order gets put in a tote, is the yellow tote you can see there, and then off it goes to pack out. So AMRs, instead of versus AGVs, they use LiDAR to navigate through the warehouse, and using a pre-taught and stored map that you drive the AMR around, or the tugger, and it learns the environment, and then it has the ability to dynamically navigate around obstacles or people using onboard software. Here's an example of a tugger arm from Vecna.
These packages, they're too big to go through our sortation system, so we have to put it on a tugger. Through e-commerce, we've had a huge increase in packages that are too big to ride through the sortation system. It could be a kayak, it could be a mattress, it could be furniture.
They're able to see their environment, know where they are in the building, know where they need to go, but also see if something gets in front of them, know they're able to go around it, and then go around it.
It's nice to see the autonomous tuggers work within the operation seamlessly alongside humans without any issues.
All right. So this is my last example and slide. So this is kind of really very new technology and shows great promise to reduce costs in an important part of the supply chain, which is the freight yards. Outrider is not only providing driverless truck cabs, it also equips each with a robot arm to connect and disconnect the needed air or hydraulic lines from the trailer. The robot is once again only able to do this dynamic task using 3D vision, which it's equipped with. And the last note before we play is human in the loop is a critical part of this solution. There's a person managing all these driverless trucks, but they can manage one person can manage multiple automatic truck vehicles. And so that adds the multiplication factor as well as upgrading that person's job skills.
A Denver area autonomous vehicle startup made its public debut this week with a more than $50 million fundraising haul and the announcement of pilot projects at several large companies. Outrider says it offers first-of-its-kind technology to help automate the distribution yards of large companies. A video issued by the company shows driverless cabs maneuvering containers at loading docks as an employee monitors the operation from a computer. Although distribution yards offer the kind of confined, repetitive environment that could make it perfect for autonomous technologies, Outrider officials noted they can also be complicated and chaotic, with human workers still performing many different tasks. In addition to moving containers around a yard, Outrider's autonomous electric cabs, according to the company, can also hitch and unhitch trailers and connect and disconnect their brake lines. Officials also said its system integrates with supply chain software already in use by large companies. Outrider is conducting tests at 4 unnamed Fortune 200 companies and at paper goods giant Georgia Pacific. The company's fundraising campaign, meanwhile, took in $53 million from numerous venture capital firms, as well as logistics giant Prologis and the venture arm of Koch Industries, Georgia Pacific's parent company. Ultimately, Outrider executives hope to establish logistics hubs that are safer, more efficient, and more sustainable. Founder Andrew Smith set a goal of rapidly retiring the more than 50,000 yard trucks in the U.S. that run on diesel fuel.
All right, pretty cool, eh? I hope that gave you a pretty good diversity of applications that are now being realized through these fantastic startups that have gotten to really put AI and vision sensing to use in a meaningful way for the logistics market. So let's see if there's questions here. Here's my information. If you have any questions about some of the vendors I showed or anything else, shoot me an email. And you can visit our logistics page at motoman.com, applications, logistics.
We do have a few questions. Looking through the list here, how many 3D vision startups are currently in the market?
Globally, probably over 100. But I would say that, and in the US, probably 20, 25. But those that are to a point with a mature product and install base is more like a dozen. and those companies also are properly capitalized through venture capital, and you typically find these companies into their Series B fund round, which is anywhere, 50
Next
million
question
and
is,
above.
are any of these startups offering a robot as a service or leasing model for their technology?
That's a good question. Yeah, we're finding more and more growth in with the RAS model, where the company, let's take Ambidextrous or Ambi Robotics for instance, they offer Ambi Pick and Ambi Sort their cells in a RAS model, and then it's or the company can capitalize it. But we're seeing more and more acceptance and an offering of that. Under RAS, they would continue to own the equipment, maintenance it, service it, and charge by the month, or more like an operating.
Right. There were some questions that were asked and were answered online by the moderator, but I thought I would just go ahead and go through those just for the benefit of everyone else in the audience. Somebody asked, or Nick asked, what's the role of Yonder? And the answer is Yonder is a +1 software that allows the crew chief to monitor multiple lines and jump in to help with sortation as needed. And then another question was, who supplies the end-of-arm tooling for these robot vision, etc.?
It is becoming more and more prevalent that the 3D vision AI developers are more and more developing the end-of-arm tools, so it can coordinate with the use case as well as their AI, so they use the end-of-arm tool more smartly. So some don't, but it's growing.
Eric asked, does Yaskawa Motoman plan to extend the product line to offer larger DC-powered robots that could be mounted to AMRs?
That's a great question. It's been discussed, but there's nothing on the near horizon that I know of, although our parent could be working on something. They work very closely with Moonjin in Japan, and they do have a mobile AMR offering as well. So it would be more efficient.
Okay.
But
well, I don't see any other questions queued up, so I would like to make last call for questions. If not, we'll wrap it up.
Thanks everyone for attending.
Seeing any more? Nope, no more questions. So just a reminder that you can replay today's presentation as well as view past webinars on our website. Just go to motoman.com to the About menu and then Webinars. You also see a list there of future webinars that you can register for. For today's webinar, you will receive an email with a link to the replay of a recording, and it will also be on our website in a few hours. We hope to see you again at our next webinar on August 26th. The subject is remote troubleshooting and diagnostic tools. As always, we want to thank you for spending part of your day with us, and we'll see you again in a couple weeks. Thank you.